All right, we're on live, so be quiet. We're studying exponential functions today. Hoorahs, right. This is a war, baby. This is what you're going to see today. Again, basic version. You've seen this in science, I bet you, $10 in biology. But that's the basic version. If you want to, we can start adding stuff like that and making it more complicated. But we're just going to keep it simple, stupid today. Okay? Did I call you stupid? Yeah. So the graphs. Either look like that one, or that one. The exponential growth, you'll hear this as exponential growth or decay. Our population of our planet has been on growth for a long time, exponentially. Okay? So we've gone from 1 or 2 billion people in 1900 to over 7 now. That's how it accelerates. So it's really flat. It's really flat for a long, long time, and then it starts to creep up, and then it goes, and it shoots up. The more people you have, the more babies they have. And then also, life expectancy has gone from 40 to 50 years old to 78, 80 years old. You know, so people are living longer and there are more people having babies. But we're seeing the trend right now in the birth rate is actually below the death rate now. That means the population's in either stabilize or decline.
In America?
In the industrialized nations. Especially here in America, actually.
Hasn't the ages expectancy
Okay.
started to decline?
Exponential decay. You guys have seen carbon dating, carbon-14 dating, half-life. Yeah, this is what the graph of half-life would look like. So it would decrease by half, 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 and it would always come down, but it would never, ever be gone. So it would get closer and closer and closer to that x-axis, but it would never be gone. So exponential growth and decay. For our purposes, we're going to graph this. Most of the time, of course, we always start you with a table of values, right? That's the #1 way that works every time on everything. So pick some x's. -2.
0. -0, 1, 2.
Okay.
-2.
99. Now we're bumping. So plug. Now this requires that you remember your exponential or your properties of powers. Okay. You can plug 2 in. What's 3 squared? 9 times 2 is 18. What's the number for 1? 6. And 0? No. What is
6. Oh, it's 3. It's 6.
3 to the 0 is?
0.
It's not 0.
6.
It's anything to the power of 0 is 1. That's a property of powers. So the answer is actually 2. Yeah, I hate you. So there you go. Thank you for that. What is the exponent negative rule? Anybody?
You have to flip
No
it
I's,
over.
no ones.
You have to like flip it over the bar. So the denominator of
It becomes the denominator of a fraction.
that's fun.
Yeah.
So is it okay if we always use not negative numbers, like positive numbers?
You have to use negatives because it shows the shape of the graph. Yeah. So what is negative 2? Oh, stop freaking out.
Everyone freak out.
What fraction does 3 to the negative 2 give us? It's 1 over 3
What
squared.
are we doing?
Okay, you have negative 2 in the exponent. So it's 1 over 3 squared, which is 1/9. So what's the fraction?
I don't know.
2/9. So you can see how those numbers are getting closer and closer to the x-axis.
Yeah. The one that.
Yeah. Can anybody tell me what the Y-intercept is? Somebody's got it. It is 2. Go ahead and graph it. You can see 1, 2, 3. Oh, that was better. Okay, so there's our graph. Is that easy enough? So I want you to notice something, and this is not a pattern that you can fix to unless it's the simple version. That's the Y-intercept. Okay, if we start adding numbers and dividing by numbers, it changes it. But for today, that'll be your Y-intercept every time. Whatever number's in front of the 3 to the x, or the 5 to the x, or the half to the x. I think you can handle graphing those. That's what I'm looking for. Okay. The other basic of exponentials is understanding how to use properties of powers. We kind of touched on that a little bit. Oop, that's not what I want. Okay, how this has a special way to solve it. Okay, so how can anybody have any ideas on how to solve for x here?
Well, you're gonna have the table of values.
Yeah, you could try the plug and chug method. That might take a while.
Well, you said it works for everything.
For graphing
Oh,
everything.
okay.
We're solving for x. What is the value of x that makes this true?
What if you like do the square root thing, which is an x squared?
You can't do that. Nice try, though.
I would make it so like
Okay, what do you notice about the bases?
They're two.
They're the same, so what do the exponents have to be? The same. So we can, now there are deep mathematical reasons we can eliminate the bases, the 2's, and just set the exponents equal to each other. But logically, the exponents must be the same, right? So what's the value of x?
X minus X.
wait a minute.
X minus
The
4.
exponents have to be the same.
Yeah,
2x
2
minus 4.
to the 2 squared has to equal 2 squared, right?
So X minus 4.
In order for this to work, these have to be the same, right? Because like 2 squared equals 2 squared.
There has to be a one in the two.
There has to be the base is the same, the exponents have to be the same for them to be equal to each other. This is a lot easier than you're making it. You're about like here and you need to be here. What's the value of x? Jesus. Don't gangster sign me. What's the value of x?
2x minus 4.
X equals 2x minus 4, yes. You could at least throw me a 3. It's a linear equation. Solve it, guys.
Oh my gosh. I don't know how.
Is it x equals -4?
No.
It's x equals positive 4. Yeah, x equals positive 4.
Thank you, ladies.
You're close.
Minus the gang
What
signs.
made you carry all the weight?
Whatever.
Don't point that out.
Jordan, not much weight.
Okay, can we solve that linear equation? Please? Tell me you're not going to suffer next year in trigonometry, because this is one day worth of work, and then we leave it, unlike this year where we spent a month on it. All right, let's try another one.
Wait, wait. It's like 4.
What?
Oh my God.
So if I plug 4 in, does that work?
No.
2 to the 4th.
That's what I was trying to say.
Yes, it works.
My bad.
I'm going to go crawl in my hole now.
Hey, what happens if the bases are not the same?
Ah!
Did you steal my thunder? I did. I'm sorry. Okay.
Can I solve that problem?
I feel like there's a thunder stealing place.
Yes, I can, but you can't, so don't worry about it.
Okay. 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 Then. Whatever you say, doctor. You changed both to 9. You changed the bases both to 9.
No, you switch them to a 3. Am I right?
Yeah, you guys switch that base to a 3. Can I make 27 a 3?
Yes.
How? No, I can't do that. Because there's an exponent on it. I can't just divide by 9.
Yeah, so square 3 and divide by 9? Oh.
It's 27 is 3 cubed, right? Right, so we have to change 27 to a base of 3 with an exponent. 27 is 3 to the third power, so that's what we've replaced it with. And now my bases match, right? Now you can set what? She can teach anytime you want there, Miss Waterman. The first person with the answer gets a candy bar.
Why is that killed?
That's not fair. That's not fair.
Gabby.
Gabby, what's the answer?
It's what? 8 over 3. Okay, so Gabby's got 8 over 3. Here's your Milky Way sitting on here, if it's right. Kaylee. That might be right. Okay, let's see. Don't touch it.
Not touching.
Well, how do you get the kill? How do you get the kill? That's like a question.
Sorry. What's that? 6/3? Uh-oh.
I knew that.
Catch.
I got the right answer.
I'll give you a candy bar. You just give it away.
I think Gabby needs to love.
All right, so
Gabby needs to leave this class. Also, you need to leave this class. You're always so negative.
are we?
Johnny.
Okay, one more thing. Let's say all right, let us say that back in 1983.
Oh, so the year you were born, right?
Nope.
The year my dad was a freshman in high school.
Wrong
My dad
again.
was a sophomore.
The year you graduated high school.
No. I was an infant at this time, or toddler. I was a toddler in 1983.
Oh.
You're funny. You're real funny. Real funny. Give me a population number.
700.
Okay, so there were 20,000. Give me an animal.
A lion.
Cows.
What? No. You have 100 of them.
And then I heard another number.
762,000. 7.8.
7 billion.
That's dumb.
Oh, yeah, she used my numbers. Nice.
That is a large exchange.
It's exponential, actually. Okay, we're going to write a function to model the growth. Okay, listen here. These are growth models. The A is the start. A is your Y-intercept, right? For now. That's our starting point. So we're going to put 20,000 there. Okay, this is what we're going to consider year 0. Right? And then this is, what year is this?
7.
It's year 8.
Wait, 8.
Whoa, whoa, whoa.
I'm kidding, it's year 7.
Oh, really? Thanks for fooling.
This is year 0. 83 is 0. 84 is 1. 85, 86, 87, 88, 89, 90, year 7. And there were 62,000 cows. So our goal here is to calculate B. That's our goal here. Okay, what can I use? I know my A value. What can I use for a Y value? Years is X.
Cows, the population,
Yes, which one?
so the starting one.
Oh, we've already used the start.
The big one.
Halfway point.
And then we're in year 7. No exploding.
B7.
All right, so year 7 had 762,000 cows, and we started with 20,000. Do the math there. Who said that?
Gabby confused?
John's
confused.
I don't even know.
You know,
John said years of the.
What?
If that 1983 word line screwed up.
Our first year is 1983. That's year 0 with 20,000 cows. That's our Y-intercept. That's where 20,000 goes. 20,000 is a Y value, the population value. That's what our Y-intercept. Then in year 7, we had 762,000 cows. B is our growth rate. We're trying to figure it out. Okay, so value of B. Hang in there. We're almost done. What's that divide by that?
38.
Nope. That would give you a 14th root.
No. That's that question.
Okay, how do we get rid of a 7th power?
The 7th root.
7th root. The 7th root gets rid of the 7th x power. This is that math key on your calculator. You go hit 7. So on your calculator you get 7. Go into math. Find x root. Enter, and then enter your number.
What if you don't have a calculator?
You might want to go get one. Get off your butt.
Not like out of class.
Do you have a cellular phone? Computer? You have a calculator. Okay, so hit the number 7. Go into math, down to x root, and then type 38.1.
Oh, I know how to work my calculator.
1.7.
1.68.
1.7 if you round properly.
There's our model.
68.
So at what percentage, here's a question for you. What percentage is that population increasing per year?
168%.
That's 168% increase per year. Because 1.68 is your growth factor. Yep. Anybody confused? Okay, I'm done. I'm going to give you something to work on.
I don't know if
Avery, the only person sitting down here, the only person sitting down here who asked me to tap his foot. He's short.
Oh, stop it.
Do it. I'm not doing it.
Come on.